And then I'm going to divide that 9Cs into three sections. One is called the ingress and logic section, and another is intelligence and exploration, and then you have got refinement and metadata section. So let's start. And 31,000 BC, and I am inviting you to the world of art. And this is the first artistic imprint that is being recorded in the history. 31,000 BC at France. After so many years, you will see that the first human imprint has come in 18,000 BC, and we don't know where it is. And then it has gone through so many cycles, color pictures, until Rembrandt came into picture in 1500 AD, who started creating images artificially. And if you look at the next slide, this is Rembrandt himself created his duplicate image using technology. After that came the cartoon films, the Toy Stories of the world. And the last one is the Titanic movie, where the water overflow was created using AI. And then in advertisements for generating mass audience, they started creating this kind of artificial imagery. And so many software products like Aaron, Emily Howell, all these kind of products evolved during that particular time. So what I would like to tell you is that you can see that an evolution happens from a period to another period, but there is a pause in between, and then a disruptive technology comes in. A game changer comes in. We call it as a punctuated equilibrium. And today's game changer, obviously, is AI. There is a great book by Herbert Simon who told that the ability of computational capabilities, processes, algorithms, etc., open the aperture to dream. And what we can dream has got unexpected results in the industry. And finding a solution to a particular problem, today you might be using one technology, tomorrow you will be using another technology which is disruptive. And this particular cycle goes on. The cap theorems, the acid properties, all these things will evolve during a period of time, and then comes a disruptive technology. And at the same time, there is a sad thing also that if you look at the greatest technologies that are there in the world, they are all coming from a warfare. Technology is created on the loom of sorrow. An example is Al-Khwarizmi, who lived in Baghdad in the river bank of Tigris River, and he is the one who created the word algorithm in the year 850. And after a few centuries after, you can see that the same place is in flames because of the Iraq war. So, whether it is AI or whether it is a disruptive technology, making conflict to construction, prosecution to liberation, and destruction to delight is the responsibility of us programmers and technologists. So hope we will use AI responsibly for technology, for improvements, and for creating a profound impact to the organization. And now let me invite you that all of you are listening to me. And if I am adding each experience that you have, for example, some of you are having 20 years of experience, some of you are having 15 years of experience, 10 years of experience. I'm going to add all that experience together, okay? I'm going to take your brain and I'm going to combine all these things, and I'm going to create a nice, beautiful ball of knowledge by taking all the details from your brains, your experience, your knowledge, your capabilities. And this is for banking because all of us are from the banking domain. Similarly, for healthcare, there can be another one by combining all the brains. and there can be something for logistics or trade. So we create all these things and combine together, and we create this big, massive ball, which is a kind of accumulated knowledge. Got it? All your experience, all the experience across the globe, I'm combining into this particular thing. And now there is a problem. I'm going to ask a question to this. Because the complete world is trained on this particular ball, the ball should know everything, right? And it should be able to give me the answer, whatever I am asking. Well, there is a small problem. The problem is, I have got only a straw. And I'm going to look through this straw to this particular ball, and what I can see is a very small thing. So even though I combined all the knowledge across, and if I am asking a question, the perspective that I'm going to get is only through the straw, and I'm not going to get the answer. A beautiful example is given here. Look at this sentence. The bank was closed due to water overflow from river. And if I am looking through a straw, I am seeing only bank closed. Bank, financial institution, closed because of robbery, because of holiday. I don't know. But here comes a magic. Let's throw away that straw and let us use this one. What is this? A magnifying glass, right? And now I'm going to use this magnifying glass and I'm going to read that same sentence, which you see here. The bank was closed due to water overflow from river. Ah, now I got it. It is not about the financial institution that we are talking here. It is about the river bank, and the river bank is closing because of there is a threat of water overflow. You got the context. You got linking the things together. Now you can use this ball not by using a straw, but by using a magnifying glass. And let us call this particular paradigm or this particular model a beautiful word that Google Brain has given. Attention is all you need. Every great paper from MapReduce onwards, GFS onwards, it originates at Google. Jeff Dean, Sanjay Gamawat, their team, they created this particular paper, which transformed the industry and created a multi-head attention and a mechanism to manage the linking of the knowledge, context of the knowledge, relationship of the knowledge. And then you are looking through the magnifying glass so that you are getting an answer. And the beautiful diagram is also there in that particular paper. The link is below there, and you will see a very complex diagram where a multi-head attention layer, a feed-forward layer, a transformer layer is giving the answer to a decoder. So there is an encoder, there is a decoder, and then you are getting the results as you want. And now, if you're looking at this, is it very simple to create it? No, it is very, very complex creation. Why? Because the energy that you need to use for creating this particular thing, the power of the machines that you want, the time it takes for creating this particular product, and the cost. 10 HDB flats for a month, the power can be used, or it is used for creating this particular model. Imagine. Energy is a big concern. And also, when you're asking ChatGPT or any kind of transformers framework, why it is giving you an answer before 10 months. Because the model is trained before 10 months. After that, there are a lot of human evaluation on the top of it to make it a linked, consolidated knowledge, which can be served to the audience. Well, attention is the key. And you already understood what is meant by attention. Never look through a straw, but by look through a magnifying glass. Remember this particular game that we used to play in your childhood? That one person is giving a small secret word to the second person is telling the first person's word plus his own or her own secret to the third person, and you are going on whispering until 25th person or 30th person, you forgot what the first person has already told. And that's exactly what's happening in the world of convolutional neural network, artificial neural network, recurrent neural network, all these kind of neural network technologies. They were able to do some handwriting recognition. They were able to do some small tasks effectively, but they were not able to get the context of a bigger picture in order to analyze and in order to give the results. But GPT or transformers has changed that attitude. And the next important thing, massive parallelism, they gained that particular knowledge from the great MapReduce framework of Hadoop, where you will be chunking the information and parallelly executing it on GPUs or TPUs so that the speed and scale is achieved unlike never before. And the third is obviously the zero shot learning, a very important concept. In the previous generation, all the AI frameworks were used in order to create only one task at a time. But now you have got an emergent learning, like a human brain, that you are teaching something, and the human brain is able to analyze the things which are not only taught to it, but like create a poem for me, create a video for me, create an image for me. This is called zero shot learning. All these things coming together, will it affect the humanity? No. There is a great news 10 days back that AI cannot participate in getting an Oscar award. Well, that is good. So, if we are taking an example, and let's come to banking. There is a fraudulent transaction, $15,000 to an unknown or unusual recipient in an unknown country. How the encoder decoder transformers will work. On the left hand side, you will see that there is a multi-context attention. It is going to split your words, attach a geospatial coordinate, understand the relationship, and then it will go to a feed forward, which will do a risk scoring and give to the multi-head attention to the right side, which is the decoder. And it is going to analyze the same cycle again, and then finally takes an action. Lot of companies and lot of organizations across the globe uses now AI for AML. We used frameworks like Mantas, etc., in order to create the manual rules, and that manual rules is going away. Why? Because now you got a larger context, you got a magnifying glass. Now, I'm not telling anything exhaustive here, and I'm not here as a procurement person for your organization. But roughly, when you want to create an AI stack and an agent-first enterprise, you need so many tools that you need to evaluate and create it. Always remember that in an AI framework, you need agents, you need tools, you need indices, you need memory, chains, prompts, and models. These all should be cohesively combined to create that AI agent stack. And that's up to your organization to create it. So, what are we going to do? We are going to make a change from a data first enterprise into an agent first enterprise. Everywhere we are going to have agents. And if you look at the traditional example, there is an ETL team who will be using an ab initio, data stage, Informatica, Pentaho, talent of the world. They're going to take the data from the source system and they're going to do the manual mapping and creating an ETL or ELT according to your choice. Then it is going to store the data maybe in a Teradata kind of OLTP or OLAP database. Or you might be storing it in S3 or an HDFS if you are not moved away from Hadoop. And then you are going to look at your Hive Metastore, connect it, and then find out what are the components that are needed. Create an Impala driver, JDBC, connect with your Power BI tool. There is another team And then finally, the task is getting completed. Your report is kept in SharePoint, or you are sending as an email, or the people can use business objects and Cognos and Power BIs of the world. Well, just look at bottom. What is going to happen? The entire AI, UI, the UI UX is going to change. Please look at what Satya Nadella has told sometimes back, that there will not be any UI. There will be only agents. And all that is going to happen is that the user is going to tell what should happen in an agentic enterprise, telling that, okay, I want this particular report to be created, and one agent is taking it. The agent gives it to a sub-agent, and it collaborates with that particular agentic cluster, and then finally brings that particular result to back. See how beautiful the paradigm is. And now, we are all talking about 9C architecture and what are the components of 9C architecture. And if you look at the way that I used to give a demonstration of this architecture everywhere, we used to draw this particular diagram. There is a connect layer where you will be connecting to any kind of data sources that you have in your organization. And then there is a change data capture, there is an ingestion layer, and then there is a storage layer. And then there is some access layer that consume there is there. Organizations spend lots and lots of dollars for creating tools like IBM Business Glossary or Informatica Metadata Dictionary, where you will be putting the meaning and the custodian, the PII information, the HIPAA information, the GPDR information, all these things into a manual model. And then finally, you are going to get the data out of it through, again, manual interfaces. Change it. All these connect, compose, contain, consume, converge, control, all the C's that you are seeing are now going to be what? Agents. And the AI native implementation is going to use a new model, that architecture as code. It should visualize the relationship between the 9 components. Do you need all these 9 components always? Sometimes you may not need, depending upon your use case. Why can't your agent decide that for this use case, I am going to use only 3 of the 9 C's? In some other use case, 8 of the 9 C's. Leave agent that intelligence to build and use which of these components are there. Holistically, all the 9 C's are there, but optionally, they are used. So, what is the problem with the traditional ELT and ETL that you do? Your relational databases, of course, asset properties, everything is there, code rules, all are beautiful. They are either schema on read or schema on write. Of course, relational databases are both schema on read and schema on write. What about JSON? It is schema on read. What about Hadoop file system? Schema on read. What about Parquet? Schema on read. The rigid schemas and entering the manual metadata, the latency that is going to be affected. Why? Because you don't know from where you are ingesting the data and where your destination is. Have you ever gone through the number of hops? Have you paralyzed that ingestion? So, rather than single source of truth, now we are moving to single source of intelligence. A self-refining infrastructure. And a great technology you can use, reinforcement learning. And add a human factor also, you will get an HLRL, human loop-based reinforcement learning. When it is learning, it is asking the human intervention, and you are telling, approve, okay, go ahead, and refine it in a better way. A self-healing, self-refining, these are all the buzzwords that are being used in the AI native agent first enterprise. So, collaborating all these components, which is a similar concept that I mentioned, you can use a neural pipeline mapping where the system is predicting the most efficient path. We solved the minimum shortest path algorithms much before. In operation research, we have solved all these problems. Now tell the agent to do that intelligently without giving manual instructions, and make sure that it uses the best possible path from the ingestion to the storage to the consumption. Great lessons you can learn, and I will share you one in a while. So, what should the Connect agent do? Most of you, most probably, even if you are using a commercial tool like Informatica, under the hood for parallelization, you might be using a Spark or a Fling-based mechanism to store the data or to ingest the data. Are you using push-down predicate? Are you checking whether there are primary keys available in that particular data? Are you making Spark retries parameter when you are ingesting the data? Are you skipping the records when you are ingesting the data? These are all called transient errors, and very well the people can correct the transient errors. And what is meant by transient errors? The obvious errors. You can do a retry, you can get it. But what about the non-transient errors? Out of memory, a null pointer exception when you are ingesting the data, gone. Your Spark cannot retry. Make it agentic. Tell the agent to intelligently look at that particular log. So somebody told me that, oh, I am having Grafana or Prometheus integrated with my platform. I am going to look at the logs and I'm going to ask AI, what is this particular problem? AI is going to give an answer. That is just doing a lookup. Okay, you store all the errors and all the error descriptions in a database and you look it up. What is the need of AI there? Transient and non-transient errors should be captured, and intelligently, automatically, the agent should be capable of correcting it in an appropriate way. Then you got an agent first connect. Well, in the traditional way, what you used? You used a dead letter queue, skipped the records. And all the records are going to put it into a trash can, and then you are going to open that and then see, hey, why this record is failed, correct? Why can't it be made a robotic scan while you are ingesting the data? And when you are ingesting the data, please look whether something is to be applied or not. And there itself, you correct it, as you see in the right-hand side, the magnifying glass again coming into picture. So all throughout the presentation, you will see that analogy of straw versus magnifying glass. Right? So, well, that is summarized at this particular point. And now let us go to the compose agent, which is the next C after connect. What is the orchestrating platform that you are using? Maybe Airflow, maybe DBT, maybe Astronomer. What is the problem? You manually wrote the DAG, right? You told when the data is to be ingested, where the data has to be go, where to read that particular parameters, how to create it. No. AI promise is making more productivity from you. And the way that you are going to do is, if suppose you are looking at a DAG, you can just create the DAG by asking an AI agent to build my DAG. All these DAGs that you are seeing, I'm using Airflow for this particular example, is created by an agent. And how the agent will decide what is to be used? Because now you know the context, you know the magnifying glass, you are now knowing that what is the connect parameters are going to be, which database it is going to connect, everything you know very well. So depending on that, you are now going to apply that in order to create a predictive scheduling, as you see in this particular part. And then you are telling the AI, do the auto provisioning. Great. There is 1 million record, 2 machines may be enough. there is 1 terabyte, maybe 10 machines are needed. Why that auto provisioning and the predictive scheduling be done by the requirement of the connect? That is how you will be intelligently creating an orchestration platform. Next, C, after connect and compose, is contain. This is great. Are you using Snowflake? You are using proprietary format for storage. Are you using Delta Lake? You are using proprietary format for storage. Are you using any database? You are using proprietary format. Now, the world has grown. Why can't your polyglot persistence layer be a combination of many formats? If you're using machine learning, use Arrow as the format. If you are using a slicing and dicing of your data, use Parquet. An optimized row columnar in some other case. Open search for, again, Kibana kinds of dashboard that you want to create. And vector database for storing the vector data so that any Euclidean distance algorithm can be applied by AI on the top of your data. And how will you decide which persistence mechanism to be used? Magnifying glass, connect, compose. You know what is the data that is going to be ingested and what is the use case. So finally, what I'm telling you is that you will have only a streamlit screen for your complete bank. And that streamlit screen is going to ask you, what do you want? And I'm going to tell, I want to ingest MySQL database or Teradata database or Oracle database into this particular format. And this is my use case. Connect, compose, and contain agents work together in order to create the result out of it. I'm airing this from Florida, very near to the NASA center where the Artemis was launched. And there is a great lesson we can learn from the NASA's mission to Mars. You know, when the people are going to moon, the communication delay is just 1 to 1.5 seconds. But when the people are going to Mars, it is 8 minutes because of the distance and latency. In 8 minutes, anything can happen. How can you solve this particular problem? Are you sitting in Boston or Florida, and then are you going to control that particular vehicle by taking 8 minutes? Not possible. That's why what they did is they built the mission control in the vehicle. So when you're storing content, learn the lessons that you learned from the MapReduce framework. Where was MapReduce? Data will never move to computation, but computation will move to data. Whenever you are doing the ingestion, make sure that you are using a local storage. One of my preferable method is I use a local S3 like MinIO, so that computation is always happening alongside the data so that I don't have to worry about the latency in writing. The IO is getting reduced. So that is the contain agent. And you can see that in the ingestion, when you are containing the data, storing the data, I am applying the redaction automatically. Social security numbers, Singapore NRIC numbers, PR numbers, or sensitive information, redact it. And make sure you are using the vaults, HashiCorp vault, ACLs, RBAC controls. That's how you will make it more and more accessible, right? So now, next is the consume agent, the querying. And you know very well, this is a part that you all will know. The data is entering, and then you are going to apply the natural language querying on that particular data. But not enough. If I am asking what is the sum of the salaries, it is giving me a number. But if I am asking compare the salaries, it will give me a table. Not enough. There is an AI agent sitting there who is going to give me the reason behind this particular shift. Why was the salary low last year? Why was the income great this month? Why the sales improved? Apply the algorithms and everything by the agent in order to decide the outcome of the consume agent. So You are moving to an agent first enterprise where the results are not only showing you the numbers, but it is giving you the reason. Right? Now, you can go through that explanation. So every slide is having that explanation so that whatever I'm explaining to you, so you can go through that later. Next, C, connect, compose, contain, consume, and now cognitive. And what is cognitive going to do? Again, a very big role. The data is coming and it is getting fine-tuned. And here is the greatest capability that a cognitive agent should display. What it is going to do is infrastructure abstraction, automated GPU, TPU, resource management, and continuous self-correction. When the results are given, can you please check whether the results are accurate or not? Is the model predicted or not? And if the model is not predicted, run an auto update onto the model to make it up to date. Well, that is the cognitive agent. And now, there is intelligence and exploration. And one of the greatest factors that I would like to see in the later future is just like MapReduce framework, where you moved computation to data, can we do the model to the data? Currently, your model is pulling all the RAG information, everything that you created in the vector database. Model AI server is different, right? That's how SageMaker will work. That's how Azure Cognitive Framework will work. Why are you pulling that particular data or the RAG from that particular RAG delivery or RAG storage into your model server? Why can't you move this computation also to that data, just like how you did for MapReduce? Good. Now, the curate is the data quality. Again, apply all kinds of algorithms, the rule-based statistical cleaning, and please think about lineage tracking, synthetic data generation, hallucination detection. All these combined together will become the part of curate agent. And remember, whether a curate is to be used or not is the first part that I mentioned to you. Which path or which C's are to be used is being governed by this particular mechanism. May not be if you're having a great front end where all the validations are done, you might not need a curate agent. You don't have sparse data and your model you want to train, it will give you wrong results and it will increase the hallucination. False positives are going to be more. How are you going to avoid it? Create synthetic data generation algorithms, fill your model with real life data, and then use that for model training, which is being summarized in this one. So we have completed curate, and now comes converge. What is converge? Our dedupe, man. The loan, mortgage, retail, credit card. I am subscribed to many of the products of the bank. How are you ensuring that when I am applying individually for all these things, I don't have duplicate records? That's how converge will work. And there is a great algorithm, which I will just show you what is the role of AI for this. And it's called Falagi-Sundar model. And I have a first name here, and the surname is Shankar. And what I'm going to do is I'm going to just put a spelling mistake in the next one, and I'm going to write it as RAVE, okay? The Falagi-Sundar model is going to start by no match, and then slowly it will be assigning the match and then finding a final score. And you can see that 56.4, it is matching, even though the zip code is different. And now I will show you the magic. If suppose the name is same, Ravi, you will see even though the zip code is different, it is telling me 100% match. Why? Because it analyzes and understands that the zip codes are very, very close and there cannot be a different Ravi. But If I change this zip code into a drastic change, I'm going to make it as 80. You see, the percentage now changed to 12.2%. Amazing algorithm. Falagi-Sundar model. But there is a problem. The problem is, again, transient and non-transient errors. Let's assume that by mistake, I did not put the surname, but I combined my surname along with my first name. Look at that. The match is 0%. Failed. Entity resolution by an AI framework, an AI agent should be used along with the greatest algorithms in order to get that particular result. And that's what a converged component should do. AI native entity resolution along with the famous algorithms. And now a catalog. This you should take very, very seriously. In your agent first enterprise, the catalog is going to be the semantic operating system. Don't forget that. The semantic operating system for your data. Any query, anything that is wanted by the business or the user, first is going to hit the catalog. And in the catalog, you have the relationship, you have the meaning of the data, you know who is the custodian of the data, you know whether it is PII or not, all these things are there. And 99.9% of the cataloging tools miss one thing. They don't store the relationship. You know, there is a great tool, and the name of the tool is called Protege. I don't know whether you have used that or not. So if you use a tool like Protege, I have created some classes like chef, cuisine type, and cuisine type has got some subclasses like Singapore cuisine, Western cuisine, etc. And then you are going to store the relationship between this as contains prepared by, rates, serves, etc. For example, a restaurant serves food. A chef prepares food. This is called a relationship. And no cataloging tool is capturing the relationship. And what is the use if you are not storing the relationship? And what is the tool that you are going to use? I have not written it here. It is called Rigor. RIGOR. And what is Rigor? Retrieval augmented iterative generation of ontologies from relational databases. An agent should use Rigor and automatically create the relationship and create the catalog you have just seen, and should combine these two together. Whenever a query is issued, it knows which are the data elements to be pushed, and you apply the security on the top of that, whether this particular user is able to access that or not. Well, that is the semantic operating system for this. And then comes control. And as you know, I don't have much here for control. Control is nothing but the proactive discovery and refinement of your particular platform. Instance resource optimizer, instance optimizer, all kinds of optimization framework will be coming here. Well-defined security. Even there should not be an admin. Admin should be an admin agent who will be telling that for this particular department, give the access to this particular table, and agent should take care of it. Why not generate this particular artifact and call either a Sentry or an identity management system or Ranger kind of tools to embed this particular request from the admin, rather than admin is creating a particular ticket? And why can't it be automated? Why can't a particular problem is automatically be positioned into Jira so that the agent does assignment of the ticket and closing of the ticket? It is going to be an amazing world. And if there are DevOps people, AWS and Azure, let me tell you, let me warn you, and the things are going to change in another maybe 3 to 6 months. And this is my prediction, a humble prediction. You are just going to write in AWS console or Azure console that what you want in plain English. It is going to do the allocation for you. It is going to do the S3 configuration for you. Glue or Athena or SageMaker or Data Factory or Azure Cognitive things. Everything it is going to do. All right. So that is control. And going beyond native orchestration, one-click deployment. How can you make this particular platform deployed in seconds? And there are people, don't tell me that I am going to write a Terraform script and all the scripts I will be combining and I will tell an AI agent to use a bash operator and all my things are done. I have deployed it. That is fooling AI. Instead, it should ask, what is your operating system? Debian, Ubuntu, Linux, HP AIX. Okay, what is the size of your data? Okay, 5 exabytes. How many users? 100 users. Can you please create a script now by the agent which will deploy the complete platform automatically? Agent first, one-click deployment for the entire enterprise. Right? So, agentic platforms are going to be evolving, and apply your thought process in order to implement this. Create self-architecting systems. 9C architecture is always a reference. You can add more Cs. You can take out some Cs, but make sure an agent decides it rather than a manual decision. So, connect, compose, contain, consume, cognitive, curate, converge, catalog, control. You got your 9 Cs, right? So, what did AI teach us? AI told that use input embeddings. Silos of disconnected data will help you to connect. Use attention layers. Observe it so that it will help you to influence. Create output which will increase the revenue, increase the benefit, increase the efficiency of your organization, which is growth. So if you look at all these three, connect, influence, and growth, that is the motto of this architecture guild, correct? So AI helps you to move from what? A doer to a director, a builder to an architect, an actor to an advocate. It is not going to take away your job. It is going to make you, as I mentioned, a director, an architect kind of the roles. Use it responsibly. And I have my LinkedIn here. And this is a sample diagram which I have just created in the last minute to show you the difference between traditional SDLC and agentic SDLC. We should be moving towards agentic SDLC. Thank you, DBS, and thanks to the organizers, Eric, Sove, Ali, everybody, for this great opportunity. And thank you very much. I'll pause for questions.
Thank you, Ravi, for that very energetic, passionate delivery of your talk. I think we all enjoyed it. We can go for questions now. I think my colleague here behind me may have a question or two. Go ahead. Yeah.
Hi, Ravi. This is Sabri here. Thank you very much for the great speech, I would say. Okay, especially I like the idea you connect war and engineering evolution. Nice. Not only engineering evolution, philosophy also evolved with the war. Okay, coming to question straight. So you very well know where the organization's current capabilities are in terms of ETL, ELT and all that. You know where we are. Okay, all the challenges, we have fragmented data and everything. If you are tasked to implement this native platform in an organization, will you reuse the existing plumbing and all that, or where will you start?
Beautiful question. Thank you very much. There will be a mixed architecture that you need to take, a mixed approach, okay? For example, I know that world famous bank in the Middle East, they told that they want to change it to a particular platform, this particular platform, but they have got more than 17,000 PLSQL procedures in Oracle. and they need to convert to that also along with this particular platform, right? So to answer to your question, 60 to 70 percentage of the artifacts that you are having can be reused and can be wrapped into an agentic, provided that particular code that you are using is no more written or no more created by the programmer. Instead, it is generated by AI depending on the use case. Second part where some manual intervention is required is where you have these tightly coupled PLSQL procedures kind of things. You may need to move it out and convert it into executable procedures which are away from database. So a mixed approach is what we should be doing to answer your question.
What would be your testing strategy once successfully implemented native, all these native, it's all very incredibly amazing. What would be your testing? How will you give me the confident?
The champion model and the challenger model. That is what we should be doing always. So whenever you are creating a particular model and you started generating it and all, that is called a champion model. And there is another one called a challenger model where a little bit of human intervention will be there. Always the challenger model is going to look whether the champion model has created all the successful artifacts or not, which is I have described it in one of the slides. And then the moment challenger model is telling that, okay, my efficiency is better, that is where they will get interchanged from champion will become challenger, challenger will become champion. This dual changing process will keep you refined over a period of time. And in a minimum of 1 to 1.5 to 2 years, you should be getting an ideal platform.
Sorry, one last question. So how do you compare the hardware cost for all this?
Okay. Uh, I have given you, and there is a very famous quotation by Steve Jobs: the people who do not know hardware cannot build great software. That's the reason why I told you a very important point in the contain layer that computation and data should be kept together. And I talked about a local S3. By using a local S3 and open standard, along with the computing architecture, you are drastically reducing the cost. Drastic, because I have real life examples of these things. Some monthly, one small enterprise here at Florida was paying about $20,000, and it got reduced into less than 5,000. Right, so to see the tremendous impact that it is making. So you should have a kind of S3 which is agnostic. Basically, at the moment you want to move at one day to Amazon S3 or Azure Blob Storage, you should be able to do that. So use something of that sort for all your persistence layer, whether it is vector database or not. Configure Milvus or VV8 kind of vector databases to use this particular S3. And then the things are very easy because you got this holistic platform in a subnet. The data is there. And as I mentioned to you, move the model also to the data, and you got a sandbox which is within your VPC, and that will reduce the problem that you mentioned about hardware. Now, coming to model training and model development, unfortunately, depending upon the data size, you'll have to use the NVIDIA 500. Otherwise, you have to use Compute Unified Devices Architecture or CUDA. Those kind of machines are used. But I think these are not a permanent basis. Why? Because once the model is trained, when you are retraining, there can be some sections that can be omitted. So do an intelligent partitioning that whenever the model is getting updated, okay, I don't want to take before last 5 years of data. So take some prudent decisions where the model training uses synthetic data more recently rather than using the entire data of the entire history of the bank.
Okay, sorry, I think the camera in the room somehow decided to take a break. Let me share a couple of questions on the pigeonhole. So for folks who are still on the line, if you can post your questions to the link that we provided in the chat. So we look at the first question here. how does the 9C architecture help eliminate data silos while still ensuring scalability, governance, and trust in AI-driven insights?
Yeah. Yeah, if you look, one slide is explaining this only. Okay, there is one slide. You can just go through that. Okay, the data silos, you are going to aggregate that particular data into open standards, and you are going to use a storage which can scale infinitely. You can use architectures like Kubernetes in order to scale it. And of course, governance and trust is by the RBAC, the walls, the unified data access layer, role-based security, data encryption at rest as well as in motion. All these things in the traditional world, we have implemented it. Everything carries. But the thing is, the decision makers are now agents.
Mm.
And the next question is, Nancy, architecture do they typically struggle with the most when, sorry, uh, which
I'll
two
read it out for you.
organizations most, yeah, can you please read it out? It's very small for me.
Yeah. Okay. So among the 9C architecture pillars, which do organizations typically struggle with the most when transitioning to AI native platforms? And how can they overcome these challenges?
One of the very important concept as well as a challenge that you are going to face is creating that catalog, the semantic operating system. If you are able to create that semantic operating system successfully along with the data and along with the relationship of the data, you are 70 to 80% ready to embrace AI. Because once you have it, any query or any decision that is going to take is going to touch on this, and then it generates that particular answer along with security. So answer your question is, most struggle happens in getting that catalog and the relationship knowledge graph part rightly, effectively.
Mhm. Okay. Are there any more questions from the people on the call? If you could post your questions.
Someone is typing a question but haven't gone through yet.
Okay. Just give us a few moments for people to
No
put
problem.
in questions. Any questions from you?
No. It's here. We are now.
Okay, we have the new question here. As enterprises move forward agentic AI systems, do you think future architecture will become agent first instead of API first? What fundamental changes are required in SDLC and governance?
It is going to go away basically, okay? Because API will not go away, but there will be a black box like LangChain or Llama index kind of architecture. I told you, to create a black box like that, you need to create agents, tools, indices, memory, chains, prompts, and models. So the tools, the tool calling, that is the one which will do your API calls. Your API will exist, but it will become an agent first architecture. So if you ask me, um, was there a microwave oven 30 years before? Yes, there was, with a very limited capability. But if you take today's, it might have bigger capability, which is inclusive of that capability. Exactly the same way. API, JDBC calls, those kind of technologies will exist, but it will become part of the tool calling, and agent will decide how to call it, when to call it, how to scale it, etc. So you are getting an additional support for all your technologies, which is the first question that somebody has asked me, right? Whether everything is going to go away when you are going to change it to an AI native platform. No, 60, 70% of the things we will reuse, but that reuse will be not directly by the human, but by the agents.
Okay, thanks, Ravi. I think we are just about time. Let me just shared what we are going to expect in the next edition of the speaker series. So in a couple of weeks' time, we have Mr. Jared Jiang from Tencent. He'll be sharing with us their approach to AI-assisted coding. And thank you again, Ravi, for very informative, knowledgeable talk today. And we will be sharing out the pack and the recording to everybody. And of course, those who miss it can actually hear more from you. And there may be questions coming through later, and we'll share that to you also, Ravi.
Yeah, thank you very much, and greatly the organizers. I appreciate for doing this kind of things. This will not, or usually do not come from most of the enterprises, as you know. But the
Yeah.
ability to grow, connect, influence, and grow, right? That is, it is highly appreciable. And thank you very much, Eric, and the entire Sove, Ali, all the team members. Thank you.
Thank you.
Thank you,
Ravi.
Ravi. Yeah.
Okay. If folks, if you could scan this QR code and send us your feedback, I'm sure Ravi would also appreciate to hear from you.
Yep,
in future,
absolutely.
more
So
talks
please
to
do
share
write
with
the
us.
feedback.
Yeah.
Yeah, thank you.
Thank
Thank
you.
you.
Thanks, Ravi.
Bye-bye.
Good night.
Bye-bye.
Thanks
Bye.
very much.
Bye.
Bye.
Bye.